All right, so now we have the quotient rule. The quotient rule is used for taking the derivative of expressions that have a division in them. Now, sometimes you can rewrite the expression so that there's no fraction or no division bar, but sometimes you can't. And so in those cases when you can't, you want to use what's called quotient rule. Quotient is meaning that, hey, there's a division happening. Now, the formula for that is you have low d high minus high d low. Got to put the high right there. Over low squared. Now, the low is just going to be the expression that's at the bottom of the denominator. The high is the expression at the top of the denominator. And if you have a d in front of it, it means the derivative of that. So we're taking the low expression multiplied by the derivative of the high expression minus the high expression multiplied by the derivative of the low expression. And then you divide that by the low expression squared. Okay. So obviously, for your steps, you have to identify the high and low functions, which is fairly easy. You just say, hey, what expression on the top? What expression on the bottom? Those are the high and low functions. Then you're going to take the derivative of the high and low function. So once you have that, you can just plug that into your quotient rule formula. After you plug it into the quotient rule formula, then again, you're going to simplify it. So you can see how this formula is very similar, or the process you do this is very similar to product rule. You just have a different formula. That's it. So let's look at an example. Okay, so step number one, identify the high and low functions, right? So my high function, so I'll write that down. And I like to write it down that way. It's real easy to remember. My high function is going to be 5x minus 2. My low function is going to be x squared plus 1, because that's at the bottom. Then I take a derivative. So d high, or the derivative of the high function, is going to be the derivative of 5x. Again, when you just have this x with no exponent, or essentially a 1 as an exponent, it's an invisible 1 here, then you're just going to take the coefficient. So the derivative is just going to be 5. And the derivative of a constant is 0, right? So our whole derivative, this whole thing here, is just 5. Now we take the derivative of the low expression, and again, we'll get power rule for both these things. Power rule will take 2 times the coefficient in the front. That will give us 2x. And when you take the 2 and subtract 1, you just have 1. So you can say 2x to the 1, or you don't have to put it there. It's understood that it's 1 if there's nothing there. Okay. Again, the derivative of a constant is 0. All right. So now you have your high, your low, your derivative of the high, and the derivative of the low. You just have to plug that into here and simplify. So let's do our formula. We have low d high. So low, which is x squared plus 1, times the derivative of high. So here's derivative of high. So low times 5, or x squared plus 1 times 5. Then you're going to subtract high. Here's high. 5x minus 2. D times d low. So derivative of the low is 2x. So times 2x. And then we divide all of that by low squared. So low squared is x squared plus 1 squared. Okay, so now we're just going to simplify. So we're going to distribute and then combine like terms. So when we distribute here, we get 5x squared plus 5. So distributing here. Now, you have to be careful here, because when you're doing the minus, you're subtracting this whole entire expression. So I'm just going to put this in another grouping symbol, okay, so that we can remember that we're subtracting everything and not just parts of it. So when I distribute here, I'm going to get 2x times 5x, which is going to give me 10x squared. And then I get 2x times negative 2, which will give me negative 4x. Okay. Now, keep in mind that when we simplify everything, we have to distribute this negative through both terms now. So that's going to give us 5x squared plus 5. And then we'll have negative 10x squared plus 4x. So be careful of that, because lots of students get tripped up on that. And then we're going to continue on with what's at the bottom, which is x squared plus 1 squared. And then we're running out of room here, so because this is the other example. So we're just going to move to the side here and finish simplifying. We have 5x squared, negative 10x squared. That gives us negative 5x squared. That cancels that out. Then we have 5 and 4x, so plus 4x plus 5 all over x squared plus 1 squared. Now, if you want to, I could expand this out by foiling x squared plus 1 times x squared plus 1, but I don't think it would really help us to be able to simplify anything. And then, so that would be that answer. Okay, let's look at the quotient rule here. Here we have square root of x over x cubed plus 1. So again, let's go ahead and rewrite this square root. That way it'll be easier for us to take the power rule. So we're going to get x to the 1/2 over x cubed plus 1. Then we can identify what's our high function, what's our low function. Obviously, your high function, I'll write it over here. Give us a little bit extra space. Obviously, your high function is going to be x to the 1/2. And make some more space here. So your high function is going to be x to the 1/2, and our low function is just going to be x cubed plus 1. Now we need the derivative of the high. Okay. So the derivative is just we take this exponent and multiply it by what's at the front. So we're going to get 1/2 x, and then we subtract 1/2 minus 1, which gives us negative 1/2. So that's the derivative of the high, and then the derivative of the low is going to be, take the power rule, 3x, subtract 1 from that exponent, so 3x squared, and then derivative of 1 is just going to be 0. Now we just plug that into the formula. So we have low, which is x cubed plus 1, times the derivative of the high. So derivative of the high is 1/2 x to the negative 1/2. So times 1/2 x to the negative 1/2 minus high, and high is x to the 1/2, times the derivative of the low. Derivative of the low is 3x squared, so times 3x squared. Okay. Now, what I'm going to do here is I'm just going to go ahead and simplify the top and numerator, and then we can add the low squared at the end. So to simplify this, we're going to have negative, we have x to the 1/2 times x squared. Okay, again, when you're multiplying these exponents, you add them. So that's 1/2 plus 2, which is going to give us, let's see, 1/2 plus 2, and represent 2 in terms of a denominator of 2. We're going to say 4 over 2. That's going to give us 5 over 2. Again, you can do that in your calculator if you want to. So we're going to have negative x to the 5/2. All right, so we're multiplying these, and let me not forget the 3x right there. So negative 3x to the 5/2. Okay, now we multiply here, and we have to distribute. So 1/2 x to negative 1/2 times x cubed is going to give us the 1/2 times 1, which is 1/2. And then we have x cubed times x and negative 1/2. So again, we're going to just add the 3 and the negative 1/2. So 3 plus a negative 1/2 is going to give you 2.5, right? And if I represent 2.5, that's going to be 5/2 as well. So 5/2. Again, like I said before, you can do that in your calculator if you like, or you can do it on paper. And then we have to distribute this to the 1. So that's plus 1/2 x to the negative 1/2. Now we can see if we can simplify here. So we have an x to the 5/2, an x to the negative 1/2, and an x to the 5/2. So these terms both have an x to the 5/2, so we can combine them. All right. So we're gonna add a 1/2 to a negative 3. Okay. And that's going to give us a negative 2.5 or a negative 5/2. So we have negative 5/2 x to the 5/2. Okay. And then all that is going to be over low squared, and low squared was x cubed plus 1 squared. So the thing about this is you do have to be really comfortable with your algebra here, particularly with exponents. And if you're adding and subtracting fractions, you want to be comfortable with that too, or be careful and use your calculator.